Hello and welcome to another video. Today we have an MSI X570 board on our bench. This is a... Where's the model number of this? There's the model number, MS7C37. No idea how MSI calls this board. Normally there's like a sticker somewhere, but that probably isn't here anymore. That says like what kind of board this is. This is probably pro carbon, pro gaming, something like that. That doesn't really matter much. We want the model number that we have there. That is the most important thing for us. And I do not remember what is wrong with this board. So before we start it up, so that it doesn't blow up in my face, let's do the initial checks for shorts. So let's start this time at the 12 volt input. That looks good. And now the 12 volt into the face. That looks also good. Then we take a screw hole for ground. Let's see that this is grounded properly. Yep. We're going to check 3.3 volts. Looks good. 5 VSB. Looks good. 12 volts. Looks good. The 5 volts looks good. Let's see. The 5 VSB is a little bit low. Let's check that in a smaller range. What is that? 350 ohms? Yep. 350 ohms. Okay. It's a little bit low, but let's not get hung up on that too much for now. At this point, if we don't do visual inspection, now we can safely plug something into here and then see. So let's get a 2200G and let's plug this into here. Let's get some of my test tools. So we're going to be using a DDR tester. This is for postcodes of DDR. There's QLEDs here, I think. Let's see, are there QLEDs here somewhere for debugging? Yeah, there are LEDs right there for debugging. But let's also get one stick of RAM into here. And let's get also the test card onto here that I have. And we want the TPM header. The header right here. Let's see if that will have good enough contact for us to see. And let's then go for power consumption. We can also do the test for the voltages if this starts up, for the voltages of the RAM. So let's give it power. 30 milliamps. That is way too low. This seems to not recognize the CPU. I do not think that we will have a reaction to the power button. There seems to be some major supply rail not running. Yeah, we do not have a reaction to the power button. Okay, so I think our 3 VSB might not even be running, because that is very, very low power consumption. And there pretty surely is something wrong with our 5 VSB line. So let's go from there then. Let's get some of these things disconnected. Let's see that the 5 VSB line isn't being pulled too low. So let's get a ground connection. Let's probe the 5 VSB. Yeah, the 5 VSB looks fine. Let's see. There's probably our 5 volt dual is missing and our 3 VSB is missing. Because currently I cannot see anything on this board. The 3 VSB is, I think, coming from this here. Is this 24-pin connector damaged? Because it seems like that our 5 VSB is getting nowhere. Let's see under the microscope. Let's go here to the slot. Doesn't look great around here, but it should be fine. Is there anything... Doesn't look like it's soldered or anything. But we definitely do not have our rails that we should have for passive standby. This is the 3VSB that should have been started up already. And let's see, we have this as an input probably, and we have no voltage here. Yeah, we have no voltage here, so we also won't have anything on its output, which is probably like this right here. Or even that one. We have nothing. So something with our 5VSB is not right. It's not getting anywhere. Can we see the trace where the 5VSB is going? Probably not. 2, 3, 4. From the fourth pin, I cannot see anything. Let's flip this board around and see on the other side if there's anything to be seen here. So it's supposed to be the fourth pin from the top. This one. It's this big rail going down here. Oh, is this just dirt? No, this is just dirt. Okay. Let's see, but this big rail is continuous. So we will have to see where that 5VSB goes and why we do not get 3VSB on this board. So let's check a board view how if that 5VSB goes through like a fuse or something before it can pass all the way to the 3VSB, or if it first has to create 5V dual maybe and then goes to there, and our 5V dual is not being created. So let's check that. So this is one of the points where the 5VSB is coming in onto this regulator. And let's see, this regulator has nothing on it. 5V there, nothing there, and 5V there. Okay, interesting. Let's look further. This right here is supposed to be the 5V dual, I think. So let's check here. This should be also present in standby. So we do not have anything on this middle pin here. We do not have anything there. And that is the 5VSB. So the question is, why do we not have this output? Is it because this here is not present? And this is coming from that chip. I've replaced this thing before. So that is probably what we are missing. Let's see down here. There's also supposed, yeah, this regulator right there. This is also being fed from the 5VSB. This is probably from that pin. Yep. And the other ones are also not this is present, but this is not present. Okay. And then also the regulator for the SIO is right. No, not that one. That one. And this is supposed to have 3V on its output if it's running and if the 5VSB is getting here. So is this the output? 2.5V. This is kind of low. It's not getting hot and the SIO is also not hot. Oh, this might be not the output. This is probably the output, huh? This will probably... No? Also not. What is its input? Oh, the input is only 4.2V. That is not correct. That is weird. Why is there only 4.2V coming here? It's hard to see because it's traveling into the board right there through these vias. Let's see. Do we get a... Let's turn the voltage off and let's see again. There was 300 ohms. Yeah, 260 ohms. So we might want to inject 5V into the 5VSB and see what happens then and go from there. So I currently have 5 volts on my tweezers, and when injecting we only get 30 milliamps of power draw. So there's definitely nothing getting hot with that kind of power draw. But let's see if the voltage is still low at our SIO, or if it's now the full voltage, the full 5 volts that should be coming in here. Yeah, now it's the full 5 volts coming in here. And it's also generating the 3.3 volts. So something about creating our 5 volts dual here is wrong. I have seen the 5 volts dual not run because of a stuck BIOS. So let's try to reset this BIOS, and we might even want to just go over to flashing it. So let's take the CMOS battery out. There should be a clear CMOS header. There's a JBAT header, which is probably the clear CMOS header in this case. Let's see, is there seems to be another one. We're just going to be shorting them all, just to be sure. And now let's connect up the power again and see if it has changed. If a BIOS reset was enough here. No, we still have very low power consumption. So let's go into detail why this 5 volt dual isn't running here. Because as far as I know, it should be present in standby mode right from the get-go here. So let's see. We have the gate takes the 3 VSB derived. We have 5 VSB coming in there and then the 5 volt dual. So do we first need... It might be that we first need the 3 VSB in order for this to work. What does this take in? No, this takes 5 volt dual in first. Yep. So the 3 VSB is only being enabled by the 5 volt dual, which is coming from here. So we will have to check this gate, I think. Let's look up what this is supposed to be for a part. So this is a P-channel MOSFET. So if the gate is low, we should have drain to source connection. Drain to source, so 2 to 3. On 3 we have the 5 VSB, on 1 is that chip, and on 2 the drain is our output. And our gate was low, I think. So why is drain and source not connected? Or did we have voltage on our gate? I don't think we did. What is this being controlled by? This is being controlled by the sleep states and by the 3 VSB VCC DRV. These are coming, yeah, from that P-channel MOSFET and that capacitor. And this is connected to where? This is just for... Yeah, this is connected to VCC3. So this is later in the whole startup. What is this? VCC5V. Where is this coming from? 10k ohm resistor to ATX power. Okay, so this is later in the startup procedure. And this is VCC5. Yeah, this is also later in the startup procedure. This is VSB5V. This is also called like that. And this is what is this? A 10 ohm resistor to ATX5 VSB. So we will have to check that the 5 VSB is passing to this 10 ohm resistor into pin 2. Let's check that that is actually happening. So let's get power in here. So we want to see the 5 VSB on that. And we want to see it here. And we want to see it in pin 2 right there. Which we do. Okay. So that is all there. Then let's see further. So pin 3 is just ground. Pin 4 is S5 mode. And for that we have a resistor right here, 47k, where 5 VSB is supposed to be connected from. And then we have the output of one N-channel MOSFET, and the gate is deep S5 and ground. So we will have to check if this is 5 volts on pin 4, and if it isn't, if it's pulled low by this, or whatever this is right here, S5 mode also. Base in this is not, this is a NPN transistor instead of a N-channel MOSFET with a base emitter and collector. Okay, so we will have to see if we have base voltage then, or base current in this case, in order that the collector and emitter is connected in order to pull this low. So let's see if that signal is being pulled low. So let's see, on pin 4, which would be connected right there, we have 5 volts. Right there. Yep. So that is present. That is not our problem. So that 5 volts reaches there as well. But I'm running out of options then. So, we have, those are supposed to be low. That is low. That is 5 volts. No, this isn't low. Pin 2 has 5 VSB. And then we only have sleep state 3 left and sleep state 5 left. And these are supposed to be low. So is maybe this MOSFET dead? I'm not too sure. What we can do, we can just short drain to source and see if this board comes to life. Let's try that. So I have some tweezers here. Let's look at the power consumption when I short these two. That was very high power consumption. I don't think that that is correct. Have a look at that. If I connect this and that. There's an amp of power consumption instantly. Is our 5 volts dual maybe shorted? Let's check that. Our 5 volts dual is shorted. That makes so much sense why that isn't working then. 2 ohms on 5 volts, 5 volt dual. That makes so much sense why that isn't running now. Good to know. Good to know. Our 5 volts dual is shorted. Let's go into injecting voltage and getting our thermal cam out and see what on 5 volts dual is actually shorted. So let's first, because I really don't know in which area we're going to have a look at. I will be having the thermal camera right there. Let me get the setup ready for injecting voltage into the 5 volt dual. So connecting one side of the power supply to a good ground. We're going to start up with a single volt. That should be enough because the short seemed to be pretty bad. I saw like 2 ohms. So 1 volt of voltage. And it takes 6 amps. And let me quickly find where those... Oh, there. Right there. Okay, let's zoom down. That should be it then already. So that you can see it. Let's put it right. Oh no, I need to inject into there. Let's put you like this. Get the ring light out of the way. And we should be in this area right here. And right there. Something right there is heating up. As you can see. Let's go from... Yep, let's get our macro lens on here. go closer to that area. Let's have a good look. That looks like a single capacitor right there that is heating up. Can that be? Let me locate it better. So let's go into the board view and see what capacitor might be connected there on that line. So in the board view, let's see, we have the 5 volts, and it's probably this capacitor that the 5-volt dual is getting into, and that is getting hot. Or this one of these two. Let's go under the microscope and see for these two. So it must be one of these two in this area. Let me see exactly with my thermal camera just for myself to see which one of these it is. And it's the bigger on the left. Yeah, now I can see it. It's the big capacitor on the left that is shorted. We can also visualize that by, let's take some IPA, get it onto this area right here. And let's now inject the voltage. I think I need more, but can you see that already? No. We need a lot of IPA. Let's get some more in here. Let's flood this area good. And now we can see it moving. And now let's go for a little bit more voltage, like 3 volts instead of 1 volt. And now you can see it clearly. Yep, that left capacitor is dead. That is great to see, great to find. So let's get rid of him. And let's clean that area a little bit. It looked very gunked up. So just using the IPA that we had. Just going to scrape it a little bit here. And let's remove that capacitor. So what we are going to do, I'm going to be taking my soldering iron. And we will be flooding this thing with a lot of solder on both sides. And we're just going to be trying to remove it like that. So that we don't stress the board too much, just heat it up from both sides at once. And trying to get rid of it. Like that. And gone is the shorted capacitor. No capacitor, no shorted capacitor, as we like to refer to it. So let's clean this area up. Cleaning up our solder pads. And now getting rid of all our flux right here. So area looks clean. Let's now do the resistance check. So resistance on our 5-volt dual is now high. Let's go into a higher range. Let's go in a 20k ohm range. And there we can see 1.3k ohms on 5-volt dual. Very good to see. Let's get rid of the injecting voltage setup. Let's go to the overhead view again. So big moment of truth. As soon as I hit the switch, I want to see 120 milliamps or something like that of power consumption. Ha! That is not what I wanted to see. That is 30 milliamps. Do we still not have our 5-volt dual? Let's see now. Let's go into voltage. 1.6 volts. Is it getting hot? Why is it so low? 5 volts is there. 1.6 volts from there. Why is it 1.6 volts? That is very weird. Did it get damaged? Let's once more connect the 5 VSB to the 5 volt dual now by ourselves. And then we can see the actual power consumption. There you can see it, 130 milliamps. And I bet if I now try to turn it on, it would turn on when doing that. So we might need to replace those components there. They might have been shot. So let's see, connecting this and that and turning on the power button. Yep, it definitely it turns on. As you can see now, we have a CPU LED, we have changing amps. Let's see. We might even be able to get a picture out of here with having it jump started like that. Let's see for the post screen. That is still the old post screen. We are on a boot LED and there's the new boot screen. Yeah, it definitely turns on now. But that was after I jump started it. And I think our MOSFET is dead. Yep, there is the board on. If I now turn it off, we're back to the state that I cannot turn it on. Now the board is off. You can see 32 milliamps. Yeah, I think something there is dead. It's what is more likely? Is it the MOSFET or is it the control chip? I would think that the MOSFET is probably dead, because it will have taken all of the it will have had to provide all of the voltage to that shorted capacitor, and I would expect that it has died in that process. So let's get rid of the post screen. So we're not quite done yet. We will have to replace this MOSFET P06P03A. So let me see if I have a replacement of that on any of my boards. One moment, please. And right here we have a P06P03A on a completely damaged board. This was my very first attempt on replacing a PCH with a reworkstation back in the day. This is like, it's been, I think, 2 years since I did this mess. And this board is still a great donor board to me. So let's desolder that. And if necessary, I think we also have the control chip right there that we might need. So let's first get the MOSFET off. Try with that. And if not, we will come back for that control chip also. So let's get some solder onto here, onto each and every pad. Some leaded solder that we have a lower melting point, that it will be easier for us to remove this thing. Kinda like that. Each pin has some leaded solder on there. Let's get our hot air station and take our MOSFET off of there. The MOSFET is out. Let's now go to our original board, our patient, and let's unsolder the MOSFET from here. Let's do the same. Let's add some flux onto here, and we will get leaded solder onto here. Get it on each of the pins and also onto this tab right here. And let's now get the hot air station and blast this thing off of here. And while the board is hot, let's get the replacement into here. The completely baked chip. Oh, and that is shifted a little bit too much for my liking. Should be fine. Like a new MOSFET, right? Let's clean up the area while everything's hot here, so that we can get rid of all of the burnt flux. So area looks fine now. And let's now see if we have the power consumption that we want and actually have 5-volt dual. So, moment of truth number 2. There we go, 130 milliamps. That is what I want to see. And now we will have our 5 volts here. Let's see for our 5-volt dual. Right there. 5 volts. Very great. And just once more now, just to see it. Working perfectly fine. We're going to be connecting everything up. And let's hit the power button and go for a victory lap here. Let's get the pause screen in here and actually hit the power button while it's connected. And not again getting off. There it is. And now we can have a look at the post right here. CPU LED, boot LED, 2.7 and 3 amps. We should get a new picture every second right there also. Let's see. Going through boot codes. 5 amps of power consumption. There is the new picture. Great to see. Let's get an actual BIOS splash screen in here. Let's connect some USB. Oh, there's an actual BIOS splash screen. It already did that by itself. And as you can see, we can now go through here. And yeah, that is great. A shorted capacitor on the 5-volt dual line that has destroyed a MOSFET that is creating that line. And that's all we had to change. So the spot got a brand new MOSFET, one less capacitor, and everything is working great. Love repairs like this one. I hope you enjoyed the video. I hope you learned something in this. All of my tools, as always, are linked in the video description. This was Mainboard Medic. Thank you very much, and goodbye.